Okay, hello everybody. Right, today we are going to explain how the mass spectrometer works, and especially looking at how it pushes the ions along and how that works. And there's two main ways of doing this, so I'm going to show you today how we do this. Okay, so what is it? A mass spectrometer is the method of measuring atomic and molecular mass in the sample. To do this, we use a mass spectrometer to fire the charged ions at the detector and we analyze these results. We can create from these results bar charts from the one at the bottom here. This is for chlorine, so 3 at 35, 1 there, so if you do the mass you get 35.5. And we can work out the chemical composition of many samples. Okay, so the mass spectrometer, it has three main areas: the ionization area, the analyzer, and the detector. Most of the experiment is done under computerized control as it's more accurate and reliable. You can get a lot closer to them what we will be guessing the results to be. Okay, so a little bit of information about the ionization area. The sample has to be ionized before sending it off. We usually do this in a liquid or gaseous form. And we do this by sending very high streams of electrons, usually in laser. We ionize this by knocking off the electrons, forming a positive charge. And there is an equation at the bottom to show how this works. As you can see, you got your gaseous sample. We're firing an electron at it, and now we've got an ion being formed, which is still a gaseous form, and 2 electrons being given off. Okay, so the analyzer. This is basically where we get all our information from, and the two ones is the time of flight and deflection. The time of flight measures how long it takes for the ions to reach the detector. They produce an electric field around the mass spectrometer, and they all are given the same kinetic energy, and they accelerate. And we do this, and we measure the time it takes for them to hit the ion detector. Deflection. We accelerate it. It's a bit curvular. It's in a curve. This one you'll see in this in a second. We accelerate the ions in the magnetic field. We measure the separation of the ions, and they can therefore work out the chemical composition from this. Okay, so I've made a little program to show you how time of flight works. Okay, so if we open the door here, and we put the first sample in, and we shut the door. It's a bit of a dodgy door, but anyway, we're going to ionize it, and then we're going to fire it away. And here we go, it has reached the ion detector. We have measured the time, and it's accelerated here, and that took a certain amount of time, and it will be faster than this one because that has a smaller mass and this one has a bigger. So we're going to do the same with the bigger sample. We're going to fire it along, and it's now hit the ion detector, and as you could see, it probably took a little longer, and this because it has a larger mass. And once again, we see the second ion travelling slower due to the larger mass. Okay, so when I said there was a curve, basically this is what it kind of looks like. I couldn't make it to the best, but it's good enough. Okay, so we're going to do the same principle. We put the ion in, we're going to send it away, and it hits here. It was quite largely deflected by the electromagnets. Put our second one in, close the dodgy door, and we fire it again. Now you can see it's not being moved as much, and basically we cannot see it being deflected less. And this is due to Isaac Newton's second law of physics, F equals ma. I'm sorry I haven't done them in capital letters, I'm a stupid boy. Okay. But let's talk a little bit about the detector. You will need to know this. The detector only detects one beam of ions. As the ions reach the detector, only the ions which are in the beam in the open zone of the detector will be able to be detected. Bit of a word crunch there, but if you need it, pause the video and you will understand it in the end. The other ions will hit the sides of the wall of the electrons, and this will be passed to the metal box, which neutralizes them in a vacuum, and it sucks all these electrons out. The ions which pass through hit the back of the wall, and this leaves a gap. And basically, I'm going to show you how it works, so we don't really need to know all that. Okay, so here's my detector I made. Here's some electrons in the current. Here's electrons showing how they're all around. And basically, I'm going to fire my ion, and it hits here. It doesn't hit the back of the detector, it hits here. So basically, it absorbs an electron from the current around this whole circuit. It's a big box, metal box, and basically the electron starts to circle it, and then they're wished away, tuck away. We don't need to know about them because they didn't hit here, and this is where we want them to hit. Second ion, here's my second ion. It's gone straight through. What a marvellous ion it is. And now electrons are attracted to it and they're starting to spin. Once you can see, it causes a gap and the electrons shuffle over kind of and take its place. And this causes a current to form, showing an ion has been detected. So basically this is the mass spectrum, this is what we get, this is the results, we enter it into a computer and we get a bar chart from it, and this is how it works. It shows you the relative current and it gives you the mass and charge. You might have seen these in the textbooks you've been studying. It's a simple way of showing them. And as you could see, my first one of chlorine, it has 3 base peaks. Well, not base peaks, but 3 peaks at 35 and 1 peak at 75. So if you work out the maths, it comes out to be 35.5. And that's all. Thank you for watching my video.